Good morning, class. In this session, we'll be discussing the forward biased operation of a PN junction diode. Before directly jumping on to the forward bias operation, what I would like to do is I would like to give you a brief overview on the structure of a diode and then define what is biasing and the different types of biasing. So by the end of the session, you'll be able to understand the concept of biasing and how diode operates in forward bias region and its energy band diagram. Now, let us start by looking at the basic structure of a diode. As we have already discussed in the previous session, a PN junction diode is formed by combining a P-type material and an N-type material together. And to this P-type material and N-type material, two ohmic contacts are connected. The meaning of ohmic contacts is they do not have any resistance drop or they do not give any sort of resistance. Okay, they freely allow conduction. So two ohmic contacts are connected to one to a p-type material and the other to a n-type material. And this p region or the p-type material is generally referred to as anode and the n-type region is generally referred as cathode. So this anode and cathode are connected to ohmic contacts. Now, this is the basic structure of a diode. Now, moving on to the next concept, which is biasing. So what do you mean by biasing? Biasing is nothing but providing external DC voltage. Okay, the term biasing refers to application of DC voltage externally. And why do we need to apply this DC voltage externally is to set up operating conditions. As we can see, an open circuited PN junction diode no longer allows the flow of charge carriers from P-type to N or N-type to P-type region. So if you want to have the flow of charge carriers, we should externally provide it with some voltage value. So that is why biasing is necessary in PN junction diode. Now, coming to the different types of biasings, we have three types: zero bias, forward bias, and reverse bias. So what do you mean by zero bias? Means when no external voltage is applied. When there is no external voltage applied to a PN junction diode, it is called zero biasing. Coming to the next type of biasing, which is forward bias. So what do you mean by forward bias? If the positive terminal of the battery is connected to the P-type material and the negative terminal or the negative potential is connected to N-type material, then the PN junction diode is said to be forward biased. Okay, so that is when you are connecting the positive supply to the P region and the negative terminal to the N region, then the diode is said to be forward biased. Now coming to the third type of biasing, which is reverse biasing. In reverse biasing, the negative terminal of the battery is connected to the P-type region and the positive terminal of the battery is connected to N-type region. So these are the three different types of biasing. So biasing is what? Providing of external DC supply voltage. Now, coming to today's topic, which is forward biased operation of PN junction diode. So as already discussed, forward biasing means what? Connection of the positive terminal of the battery to the P-type material and the connecting of the negative terminal of the battery to N-type region. So what happens when you connect the positive terminal of the battery to P region is, since we all know P region has holes as majority charge carriers. P region has holes as majority charge carriers and holes are positively charged. So what does this positive terminal of the battery do to this positively charged holes is it will repel them. That is, the holes in the P-type region are pushed towards the junction, and similarly, the negative terminal of the battery pushes the electrons, which are the majority charge carriers in n-type material, towards the junction. So the positive terminal of the battery repels the holes present in the P region, and the holes, they move towards the junction. And similarly, the negative terminal of the battery repels the electrons in the n-type material, and the electrons move towards the junction. So as you can see here, since there is movement of charge carriers, we get current. And see, this is the direction of how the current flows in the circuit. The positive terminal, since it repels holes, the holes move towards the N region. And since the negative terminal of the battery repels the electrons move from N region to P region. And the arrow marks here indicate the conventional current direction. Conventional current direction is always the electron movement, which is opposite of the hole movement. Now, as I already told you, at the junction, we have depletion region. So what happens to the width of the depletion region when you forward bias a PN junction diode is? The width of the depletion region gets decreased, and the flow of charge carriers from N region to P region and P region to N region takes place. So here you can see here the electrons from the N region are moving into the P region in a continuous manner. And this movement of charge carriers will be continuous unless and until we remove the biasing. Till the biasing is there, we have the movement of electrons from N region to P region and the movement of holes from P region to N region. Since electrons are moving from N region to P region, the movement of free electrons gives rise to a current called electron current. And similarly, holes, they move from P region to N region, and they give rise to a current called hole current. So the total current in a PN junction diode is summation of electron current and hole current. So the total current in a forward biased PN junction diode is electron current plus hole current. And coming to the energy band diagram of a forward biased PN junction diode, as we have already discussed, the electrons, they move from N region to P region. So while moving from N region to P region, they need to overcome the potential barrier over here or the depletion region over here. And since we have already discussed, the width of the depletion region decreases, which is diagrammatically represented over here. It allows the flow of electrons from N region to P region. But as you can see over here, when the electrons from the N region, which are in the conduction band, when they cross over to the P region, they drop certain amount of energy and they are pushed into the valency band. Okay, so generally the electrons which are present in the conduction band of N region, when they cross this depletion region or the potential barrier, they drop energy and they are pushed into the valency band. So this is the energy band diagram of a PN junction diode when it is in forward biased condition. So this is the operation of PN junction diode in forward biased condition. So in this session, we have seen the basic structure of a PN junction diode. Then we have seen what is biasing and what are the different types of biasing. Then we have seen the forward biased operation of PN junction diode and the movement of charge carriers when the PN junction diode is forward biased and the directions of different currents. And also we have seen the energy band diagram of a forward biased PN junction diode. So these are some of the important terms that you need to remember: forward bias and reverse bias. In the next session, we'll be looking at the reverse biased operation of PN junction diode. Thank you.